Have you ever wondered how satellite images are classified? How do we differentiate between water bodies, vegetation, and urban areas in a satellite image? The answer lies in a process called supervised classification. Imagine a vast jigsaw puzzle, where each piece represents a grid cell in a raster GIS database. These pieces, or grid cells, can be classified into different groups or classes based on their similarities. This process is akin to sorting the jigsaw puzzle pieces based on their colors or patterns. The first step in this process is the creation of training sets. These are groups of grid cells that share similar spectral reflectance values. Think of these as a guide or a template. These grid cells are manually selected and interpreted from a satellite or aerial image. They should be homogeneous, meaning they should share similar properties, and they should represent various features of interest across a landscape. The next step involves the use of a multispectral image. This is an image that carries multiple bands of electromagnetic imagery. The spectral signature values, which can include the colors red, green, and blue, as well as near-infrared and other bands collected by a particular sensor, are used to define which grid cells in an image are members of the same class. Output. Once the training sets are defined, algorithms or statistical models step in. They use these training sets to assign a class to each grid cell of the image. The training sets can be informed through field surveys, but due to cost constraints, they are more often defined through image interpretation. Output. To summarize, supervised classification is a step-by-step process involving the creation of training sets, the use of multispectral images, and the application of algorithms or statistical models. These steps work together to classify satellite images into different classes, helping us to better understand and interpret the world around us. So next time when you see a satellite image, remember the intricate process of supervised classification that helps differentiate between a lake and a forest, or an urban area and a desert. It's not just about colors or shapes, but about understanding the underlying spectral signatures and using advanced algorithms to make sense of them.